Hello and welcome to the Z Hut. Today I'd like to show you how you can Bluetooth control two DC motors with a smartphone app. Now this is a pretty easy project to do. This might look complicated, but it's actually very simple to set this up. Real easy. If you're a beginner using Arduino, this is a good project to try out. It's real easy. All right, what we'll do first is I'll go through and show you the circuit and how everything's hooked up. Then we'll go and we'll take a look at the app. Currently, I only have Android app, and I'll bring that up in a minute. I know the tablet's off, but the app is on here, so don't worry. And then after I show you the app and how it works, we'll go over to the Arduino sketch and show you how that works. And this is all real easy. Real easy. So if you're a beginner and you're looking at all this like, wow, that's a lot of crap, don't worry about it. It's real easy. It's just mostly jumper wires. Everything's modules. So this is a real easy project to set up and play with. All right, well, to start with, of course, we have an Arduino board. Now, I'm using Arduino Nano, and that's this right here. Now, you can also use this if you don't have a Nano. If you have an Uno, which is one of the most common boards, this will work fine. Work perfectly fine with Uno. Or if you have the Mega, or there's lots of different ones. I'm not sure if this will work with the Lily Pad or not. Guess you'd have to try that out yourself, but most of the Arduino boards, this should work with completely fine. Then next, we have an HC06, and that's this little module right here. This is the Bluetooth module. This allows the communication between your Android device and the Arduino. You can also use an HC05. That'll work perfectly fine. Work perfectly fine in place of HC06, but I like the HC06s because they're just slaves and we don't need a master for most of the things we do with the Arduino. And if you don't know what I'm talking about, I've got another video on the HC06s and how to hook them up and that stuff, and I'll put a link in the description below on that. All right, next we have a logic level converter, and this goes along with the HC06. Most people use voltage dividers because the HC06 and the Arduino is 5 volt logic. HC06 is 3.3 volt logic. This just converts the 3.3 to the 5 and the 5 to the 3.3. Now you can use the voltage divider, but I recommend just use a logic level converter. They're cheap as heck. You're talking like $1 for one of these, and if you order a bunch of them, less. Use them. Otherwise, if you want to do the math, figure it out, you can use a logic level, or excuse me, you can use a voltage divider in there. And the receive, you don't need it, just the transmit, because it can't handle the 5 volts coming into the board. It'll actually burn it out after a short amount of time. All right, moving on. Next, this is what actually drives the DC motors, and this is an L298N dual H-bridge. Now, most people see these and they think, well, that's for driving the stepper motors, and that's what most of the time people use these for, driving stepper motors. But they also will drive 2 DC motors, and that's kind of originally what they were come up for. And these are also extremely cheap. I think I paid like $2.50. somewhere in that range, and I ordered it from overseas. I can't remember, it was China, Taiwan, somewhere like that. I ordered this, and I got it about 2 weeks after I ordered it, and they're cheap, real cheap. You can, if you're in the United States, you can order them here, but it's going to probably be like $4 or maybe $5, and you'll have it in a couple days, but it's your choice where you want to get the parts from. Next, we got 2 DC motors. Now, these both look alike, but one of these is rated for 12 volts. The other is rated for 15. If I remember right, I got the 15 volt one is this one, and this is the 12. They will both work on this. It's just one of them will turn a little faster than the other. And these were the closest motors I had, and I figured to use them for this tutorial. Oh, another thing to add before we move on. If your motor uses less than 12 volts, if 12 volts will smoke it, do not run 12 volts into your L298N controller. It'll smoke your motors, unless there is a way around that. When you set your PWM, we'll get to that in a couple minutes here, but you'll have to keep that down so you're not sending the full 12 volt to your motors. All right. Well, next I'll show you how to hook up the L298N. I'm not going to show you how to hook up the HC06, because if you don't know how to do that, I'll put the link in the description below, like I said, and I'll have a video you can check out on how to hook these up to your Arduino board. So I'm not going to cover that in this tutorial, but this will cover. And don't worry, hooking HC06 up is real easy, especially if you get the logic level converter. But if you want to use a voltage divider, it slightly more complicated, but not much. But watch that video if you want to learn about that. All right, now on to the L298N. I've got one right here. It's the exact same thing as this one. Exact. Now, you see, there are 2 jumpers on here. Now, if you leave them jumpers on there, you cannot pulse width modification to change the speed of the motor. It'll just be full. Now, if you pull these off, and they're real easy, you just grab like that, pull them off, and you'll want to take both of them off if you're going to be setting up like I do. And you see there's the top 2 pins. You ain't going to use them. This pin right here is the pulse width modification for this side. This is side 2. This one's the pulse width modification for side 1. That's that side, and it's got out 1 and out 2. And this side's got out 3 and out 4. So these are your 2 DC motors. DC motor 1 would be here, and you'd want to put positive on out 1 and the negative on it on out 2. And the same thing on this one, positive on 3, negative on 4. Now, a little tip, if you get this all put together and you run it and your motor's not running the direction you want it to, just switch the 2 on that motor, and that'll fix that. Otherwise, let's get to the connections. Now, there's 4 in the middle, and 4 pins that are in the middle. You got your outside there, your outside here. Those are the pulse width modification pins, but your 4 in ones. Now, there's pin 1, 2, 3, and 4, and on the board it says IN 1, 2, 3, and 4. Okay, simple. IN 1 is going to be your pin out 1 here. number 2 is going to be your pin out 2 here. Pin 3 is going to be your pin out 3 here, and pin 4 the same thing. And that's how you hook that up. Now to the Arduino board, what we have set up is we're using on the Arduino board, we're using digital pin 2, 3, 4, and 5. Now digital pin 2 goes to N1, 3 in 2, 4 in 3, 5 in 4. Easy. Now for the pulse width modification, and this is what's going to control the speed. These 4 here in the middle are going to control the direction of the motor. These 2 out ones, the pulse width modifications, control the speed. Like I said, this one here controls motor 1, because that's pin out 1 and 2. So I just call that pin, or PWM1. And we have that hooked up to digital pin 9, because you need a pulse width modification pin. Now this one over here for your DC motor 2, we're going to digital pin 6. Now you think, wouldn't you have them switch the other way? Well, it's just the way the closeness works on the board, and I'm using short jumpers. If you want to switch them around, you can do that. Just make sure in the sketch you switch the 2 of them. But you can do either one. You just want to use pulse width modification pins on your Arduino board to control these, because that's what's going to control the speed. Alright, now next we have the power. And as you can see here, I have a wall wart hooked up. Your first one is your 12 volt in. Now these are 12 and a 15 volt motor, so I'm running 12 volts in. Now because I'm running 12 volts or more, I can actually power the Arduino off of this. There's the 5 volt pin, which is your far one. This one over here. And if you're running less, you're going to have to power the Arduino separately, either through the USB or from the voltage in. One of the two. Otherwise, if the DC motors you're going to be controlling are 12 volt, you can power it right off this board. And then of course the middle one is ground, and you want to make sure it's common ground. Now I just have this hooked to the one ground because we're powering the Arduino Nano off of this board. But if you're using a separate power source, you're going to want to make sure the grounds are connected. You want to have a common ground between everything. And I'm not going to go into why about that. If you're curious about it, just do a YouTube search. There's plenty of people got videos on that. It's just, you want to have a common ground. All right, I think that's about it on how to set the circuit up. All right, so what we're going to do here is take a pause for a second here. I'll get the app loaded up on the Arduino device, and I'll show you this working, and then we'll move on from there. Okay, we're back. Let's fire up the Android device and show you the app. Right there. We'll click on the icon. Next, we gotta connect. Then choose our Bluetooth device, and there we go. Got motor 1 and motor 2. And we have reverse, stop, and forward. And of course up here we've got the slider, and that's the speed. So let's say I'm going to put that to full speed and then put it on forward. Oh, you can see the motor jumped a little, and it's running. I can hit reverse. You can see it jumped a little because it's going reverse. I can hit stop. Now the other motor, We'll put that about, halfway. Forward. Now she started. Reverse. Forward. And we can run both at the same time. And you can go forward, reverse, stop. And while the motor is running, you can change the speed. That's all the way down to almost stop. And I actually have it set for the pulse width modification of, I got it set at 50 because this motor at 50 just barely turns. This one at 50, it wants to turn and sometimes it does. And you can see it's not. There we go. Now I turned it up and it is turning. This is the 15 volt motor right here, number 2. That's why it's a little more sluggish than the 12 volt. And what we are set up for is actually a 12 volt, but like I said earlier in the video, I had 2 motors that were almost identical. One was 12 volt, one was 15. So I decided to use them because they looked identical and they're almost the same. But there, she's all the way up, all the way down. Oh, there's all the way down. And stop. And it stopped. Stop. It stopped. Forward. Forward. Stop. Stop. See? I got one running forward, one running reverse. Well, that's how you use the app. Now, in a moment here, I'm going to show you on the MIT App Inventor. I'm going to show you the code on this, but if you're not interested in making the app yourself and you would just like to download this app to use to play with the DC motors, I will have this on the website. You can download it 100% free. There is no cost. It's 100% free. You can use it any way you want, except you cannot sell it to anybody. That's the only thing I ask, because I'm releasing this in public domain. It's free. You just cannot sell it to anybody else. You can use it. You can modify it, do anything you want with it. You just cannot sell it. All right, we'll try it again. Both of them forward. All right. Well, I'm going to do is I'm going to jump over to the computer and I'll show you the app on MIT App Inventor on their it's actually their website, I guess you'd call it. When you build the apps, it's on their site. There is also a downloadable MIT App Inventor. If you look around for it, you can find it because it's all open development stuff. So it's free to use, and we'll just stop both of them. And well, I'll see you in just a second over at the computer, and I'll show you the app, how it's configured and made. Otherwise, like I said, you can just download this app and use it with the circuit here. And also, I will have the Arduino Code. That's free too. And you can modify it, do whatever you want. I'm putting all this public domain, all of it, public domain. Do what you want with it. I just ask you don't sell it. That's it. All right, see you in a second over at the computer. Okay, I've got the MIT App Inventor website brought up, so I can show you how you put this app together if you want to build it yourself. Otherwise, like I said before, if you would like to just download this and use the app as it is, just go to my website, download it. Otherwise, we're going to jump right into it here. All right, this is our designer screen. And also, if you've never dealt with MIT App Inventor before and you would like to modify this and have some fun with it, I'll have a link in the description below where you can get the MIT App Inventor. It's actually done online. Otherwise, there is a downloadable version, but you have to do like a virtual server type thingy to get it to work offline, and that's a little more complicated. You want to do that, just do a YouTube search. That's how I originally figured out how to do it. There's lots of tutorials. All right. So, of course, we got our designer here, and we got our motor 1, our slider for the speed control, a reverse button, start button, forward button, and then again for motor 2, the same things. Then we get the disconnect button, and oh, hold on a second. Now the app is set up to be not scrollable because I have it set up on 2 virtual screens. So when the app first starts up, the only thing you see is this connect button. Then after you hit connect and you connect to your Bluetooth, the connect button disappears and all this stuff up here appears. And that's just done. I'll show you, let's say like the start button here. Visible. Oh, that's probably the wrong one because we're using the, my bad, sorry about that. We're using the horizontal arrangement to turn all 3 of them off and on in one command. And you see it's not visible. But then you look, the connect button is visible. And what happens, and I'll show you in the block editor here in a moment, once you connect, it just turns this to invisible and turns all these to visible. All right, well, let's get over to the blocks. Before I forget, though, let me turn the scrollable back off because we don't need that. We'll go to the blocks. So what we have is our normal way that you connect to your Bluetooth. You have the list picker, which is that connect button. You've seen that big blue connect button. And when you click that, what it does is it brings this up first. It brings up the Bluetooth clients that you can connect to, and that's your Bluetooth devices that are available. So then you just click on, you know, which one was associated with this project. Then after picking, you can see here, it connects to the Bluetooth address, and then, like I said, it turns all of them visible or not, and we're using true or false statements. This right here is the list picker, and that was your connect button. It turns that to false, then it turns all those other buttons to true. That's how easy it is. The same thing if you hit the disconnect button you've seen, that red disconnect button, it turns the connect button back to true and then turns them all to false, so they disappear. Because with MIT App Inventor, if you switch screens, you lose your Bluetooth connectivity. You have to reconnect. So what I have found is virtual screens. You just make the item visible or not. I hope that makes sense to you. If it don't, do some research YouTube. There's lots of videos that should describe it to you a little better than I can probably, but all right, we'll move on. Now the slider 1, when that position is changed, and that's for the motor speed, for the DC motor 1, what we're doing is we're sending a 2-byte number. Now I like to use 2-byte numbers instead of 1. It works better. It's kind of hard to describe if you haven't done this before, but 2-byte numbers seem to work better than 1. And you can also send 4-byte numbers, but 2-byte works the best. And when we get over to the Arduino sketch, I'll show you how you take the 2-byte number and bring it in, because the Arduino only receives at 1 byte. So what we got here is we're, of course, rounding it because it'll give a decimal point when that slider position's changed. It's a decimal point, so we want to round it to a whole number. And then the slider one position, and then we're adding 1,000 to it. Now the reason for this is, and you'll see in the Arduino sketch in a moment, you have to have different values and none of them can overlap, otherwise it just won't work right. And I hope that makes sense to you. You got to have different values, otherwise they'll carry over and it comes up, you know, the same value from two different items, like two different sliders. If they were both 1,000, it'll change both of them. Hopefully that makes sense to you, but we're just going to move on because we're going to go through this kind of quick. And if you are a beginner, like I said, just check out, there's tutorials on YouTube on this if this don't make sense to you. So we got next is the reverse button. We're sending a value of 100. The forward button 300. The stop button 200. And we're going down. And of course, because we don't want the values to overlap, we're adding 2,000 to slider 2 because it's going to be sending the same values. And I have it set from 50 at the minimum to 255 is the maximum. And we're adding 2,000 to it so it don't overlap with any of the other values. Then we got the motor 2 reverse 400, motor 2 forward 600, motor 2 stop 500. That's all there is to it. I mean, this pretty easy to put together on MIT, even if you've never done this before and you just kind of look at my screen and have this and pause it and then look back and forth. You'd probably be able to figure out how to make this yourself, but otherwise just download the app off the website and you're good to go. And I will also make available the modifiable file, which you can open up in MIT App Inventor and you can go ahead and modify anything you want. I will also make that available on my website too. The APK is the one that is the app that you install, but then there's the AIA, and I'll have that, and the AIA file is the one you can open up, and you go to MIT App Inventor, open that file up, and this is what you'll see. This is what you'll see. Well, I hope this is making sense to you so far. I'm kind of running through quick, but I want to try to keep this video under a half hour, hopefully under 20 minutes if possible, but we'll see how it goes. With that, I don't think there's really anything else to go over on the MIT App Inventor app. So next what we'll do is we'll go over to the Arduino sketch. And you can also download that on the website too, of course, but we'll go over to the Arduino sketch and I'll run through and show you how that we use these numbers that we are sending from the Android device to control the motors through your Arduino. All right, well, I'll see you there in just a moment. Okay, I got the Arduino sketch brought up here in the Arduino IDE. And like I said before, you can go to the website and download this. So let's get to it. Now to start with, we got to define some pins. And these are the pins that are going to the L298N from the Arduino. And we've got defined pin number 1 is going to be digital pin number 2 on the Arduino, and that's going to be the positive side of your motor number 1. Then we're going to define, and we're going to call it pin number 2, and that's going to be to the Arduino digital pin number 3, and that's going to be motor number 1 negative. Then we're going to define pin PW1, and we're going to put that to the Arduino pin 9, and that's the motor number 1's PWM pin. Now, I was just reviewing The first part of this video I shot before I got here, and I don't know why I keep saying pulse width modification. It's just something bad that I do I've done it in several videos, but I'm sorry, it's pulse width modulation, not pulse width modification. So if you've seen that and caught on to it in the earlier part of the video, I'm sorry about that. I don't know why I say that all the time, but PWM is pulse width modulation, and I keep saying pulse width modification, but I think you kind of understood what I said anyway, and I'm sorry about that, but now we'll move on. Then we're defining pin number 3 is going to digital pin 4, and that's the DC motor number 2 is positive. And then of course down pin 4 on the Arduino is gonna, or excuse me, pin 4 on the L298N is going to be going to pin 5 on the Arduino, and that's the motor number 2 is negative. And then PWM pin for the second DC motor is going to be going to PWM pin 6 on the Arduino, and that's for motor 2, of course. One of these days I'm gonna remember not to say pulse width modification. Sorry, I don't know why I do it. Just one of them habits stuck in my brain. But whatever, we'll move on. Next, we're setting all the pin modes to outputs because they're all outputs, and all 6 pins are set to output. Then we're going to do our serial begin, and I'm using the 9600, which is typical. If you change this, you are going to have to change it in multiple different places. The app, of course, the HC06 or HC05 board, you're going to have to change this. But when you get them factory, in the way everything's set up, if you just run serial at 9600, everything's fine, and it's going to run fast enough for what we're doing here. We're not running anything that needs to be running light speed, so just leave it 9600. Then next, what we're doing is we're writing the 4 pins that control the direction of the motors. We're putting them all low, so that means they're all at stop. And then we're analog writing the PWM pin 1, or the PW1, which is the motor 1, DC motor 1, and we're putting that at 50. And then we're analog writing PW2, which is the pulse width modulation. Oh, I got it right that time. For motor 2 at 50. Because at about 50 they cut out, or they're just barely turning, and depending on the motors you're using, you might want to change this a little lower, a little higher. It just depends on the motor. You're gonna want to try this out, and then if the motor ain't turning when you started it up at the low, just increase it. If it's turning and you don't want it to turn, decrease the value a little. That's all there is to that. Alright, so we're going to move on here. Now, I was telling you about we're sending 2-byte numbers to the Arduino, but it's only receiving 1 byte. And this right here, do not change this. If serial.available is greater or equal than 2, it's bringing that in, and it's taking that 2-byte number, and it is receiving it as 1 byte 2 times, and then combining it to make the 2-byte number that we sent from the Android device. Hope that makes sense to you, but that's what we're doing. Do not change this. You change any part of this, it's not going to work. Well, all right, we're going to move on. Now, then we're going to do a bunch of if and then else ifs. If we did just ifs all the way down, what happens, it slows it down. If you do your first statement as if and then all the rest, else ifs, it runs quicker and smoother. Trust me, I've written many apps and done many sketches, and this is how you want to do it. You want your first one an if and then the rest else ifs. And then, of course, we got the first value coming in at 100. You remember over on the MIT App Inventor, we were looking at sketch. That, if it gets that value of 100, it puts the motor 1 in reverse. And that's what it does. It digital writes pin 1 to low, which would be the positive pin, to DC motor 1, and it puts that to low, so it's negative. Then digital writes pin 2 to high, and that puts the negative on DC motor 1 to high. It's running in reverse. Now, you'd think I'd have it forward first, but what I did is I just worked my way down from how the buttons appeared on the screen, and reverse was first, and that's why I did it this way. You can go ahead and do it your own way, but that's what I did. I just went in order of the buttons on the screen. And then you go down, if the value is 200, motor 1 is stop. Value 300, motor 1 is forward. And you can see, you know, it reverses for what the reverse was low and high. Now it's high and low. And that's how it goes. And then we're doing the second motor, the same thing. And I'm sorry, I'm jumping through a little quick, but I think if you understood what I said about the first two, you're going to understand how and what I meant about the first two on the second motor work. But then we're going to go, now here's the value. If we got a value that is greater than or equal to 1,000, and the value is less than or equal 1,255, that's the speed. And that's for DC motor number 1. So what we're going to do is we're going to analog write that to PW1, which is your pulse width modulation. Oh, I remembered to say that again. That's for DC motor 1. But then we're going to write the val, which is the value from up here that comes in. Oh, get back down here. And then what it's going to do is it's going to subtract that 1,000, that number you remember over in MIT App Inventor, we added that. Well, it's going to subtract it. So then we're going to be writing a value of about 50, or actually an exact value of between 50 to 255. And that's the analog write. 0 is the lowest, 255 is the highest, and that's full on, 0 is full off. And you remember I showed you I had it set up for 50 minimum, and that's why I didn't put 1,050. You can change this because your motor might need more, less, and it won't overlap with anything else, so I just left it that way. And of course, here's motor number 2's speed, and it's the same thing. Now, look at this sketch. It's super short, super easy. And like I said at the beginning of this tutorial, this is an easy project for a beginner. There might be a few things that you didn't understand right off the bat. But do some Googling and check out the things you don't understand, or look for some other YouTube videos that that'll show you, the little spots where maybe what I was trying to teach you didn't make sense. try somebody else's video, well, maybe you'll have a little better luck. But just trying to help you out, and I'm hoping you found all this information useful. With that, I think we can wrap this tutorial up. I would like to thank you for joining us here at Z-Hut today. If you did find this information useful, please give me a thumbs up. I would appreciate it big time. If you have any questions, you can leave them in the comments below. Otherwise, I'll have a link for my Facebook page too, and you can leave a question on there, and I'll get back to you as soon as possible if you got a question, and try to help you out the best I can. Otherwise, also please consider subscribing. I put videos up. I'm trying to at least do 1 or 2 a week, and maybe more. It just depends on, well, the parts coming in and what kind of ideas I get, and thinking of what kind of videos I can do. So that's that. All right, have a great day and have fun building. Till next time, later. And remember, everything's better with Bluetooth.